Thanks for coming out, everybody. My talk will be on Ray Serve for IoT at Samsara. My name is Brian Westfall, and whether you're here for happy hour or here to hear my talk, I'm happy to have you. So first, I'll be talking about what Samsara does and how we use it for our machine learning in our products. And next, I'll talk about how we reshaped our ML inference platform with Ray Serve. And lastly, I'll go over some juicy tips for getting the most out of production Ray Serve deployments. So a little bit about me. I'm a senior machine learning engineer at Samsara on our ML infrastructure team. And right now is a really exciting time to be in our team because we have a lot of breadth spanning focuses on end-to-end ML development. And if you attended our talk earlier about our ML platform, you'd have seen where we utilize Ray to ship models on the edge, so like firmware deployments. We also conduct a lot of batch jobs for training, data collection, and stuff that comes with it, as well as cloud deployments, which is mostly what I'll be covering here. So let's talk about what Samsara is. At Samsara, we're building the Connected Operations Cloud. So what this is we're increasing the safety, efficiency, and sustainability of operations that power the global economy. So what we're really looking to do is take customers and physical operations and connect them to the cloud so people can get insights into their data and improve their operations. So as you can see, we have a suite of different products which help our customers collect data about their real world operations and make them actionable in the cloud. So our customers collect sensor data from vehicles through our vehicle gateway, as well as dash cams, their site cams, and equipment gateways. And these devices are cloud enabled, transmitting data directly to the cloud, where that data is synthesized and delivered to your dashboard so customers can make quick decisions. So let's talk about how we use AI and ML in our product. So Samsara's machine learning models serve millions of remote devices. Our primary product is our AI dash cam, which grants fleet managers oversight into their vehicle fleets, into interesting events which happen, such as detecting crashes and automatically pulling that footage, and also augmenting driver ability with in-cab alerts, such as forward collision warnings. We also provide reports such as unsafe driving behaviors so that they can be coached upon later to keep our drivers and our roads safe. Samsara also offers a site visibility product, which gives further end-to-end insight into your physical operations, starting from the destination, the warehouse. So these AI-powered cameras detect events such as movements, accidents with forklifts and vehicles, as well as connecting physical inventory movement from warehouses and shelves. So with that context, let's talk about how we adopted Ray Serve and where it fits into our ML platform. So to build these products, we designed our ML platform with the following principles. First, we wanted to empower scientists. We wanted to enable them to contribute to their apps and jobs throughout the life cycle. We also wanted to minimize the platform switches, so we didn't want to have them be developing using some other API and then having to develop some new language or API when in production. Samsara also has a big culture of operational excellence, so we uphold that we want to ensure all our systems are resilient and well monitored. And of course, everybody, the key topic of today is scalability and cost. So we wanted to make sure we're using a scalable solution. And then lastly, we want to move fast. So I think everybody here, wants to take something from development to deployment within a day. And that's what we're really trying to do with our platform. So ultimately, we chose Ray Serve for our inference platform because it provided us, okay, there's the slides generated. It's a consistent platform, so our developers are able to use the same APIs that they use in development and production, so that reduces the learning curve for our developers. We also found great scalability enhancements by adopting Ray Serve. So you might have heard earlier in the keynote that we got 50% operational reduction costs. In a lot of cases, we reduced our latency by 10x. We also just found that Ray Serve was a really good API for making our pipelines unified. So rather than having different components doing different things, we're able to unify them in a simple Python platform. And then lastly, with that operational excellence note, we're really interested in Ray and KubeRay's highly available durable pipeline guarantees. So prior to adopting Ray Serve, our backend resembled this setup. So we had multiple services performing different steps. So as events streamed in, we had data prep, model inference, and persistence happening in different steps. This was a little limiting because it required synchronizing multiple services codes in multiple languages. So we're primarily a Go shop, but ML's mostly in Python. And we also had orchestration steps that were not really optimized for hardware batching or parallel execution, which RayServe provides. So after moving to RayServe, we've started to migrate all our business logic, data prep, and model inference together. So most of all, we've started to unify our code base to a common location and language which everyone on our ML team can use so deployments can be better self-served. We can still retain our need for dynamic generation of business logic based on incoming traffic, and we get the scalability and optimization benefits of accelerator support, batching, parallelization, as well as rapid auto-scaling provided by RayServe without having to write any of the sophisticated orchestration layer ourselves. So I want to jump into the meat of things and provide a lot of tips and tricks for you if you're starting to look into RayServe and deploy it. So first off, I think this is a really underrated feature, but Ray provides tooling for profiling to make the most of your computation. So as mentioned at today's keynote, this is how we got a big component of our 50% cost reduction, was really just like analyzing the data. So RayServe makes it really easy for you to go in and just, as you submit a bunch of requests, when you're in the Ray dashboard, you can go in and hit the CPU profiling tool and really see like where a lot of the time is spent. So what we found is that a lot of the time is spent on data prep, downloading, reading, or transforming data, which was really obvious once we looked at the flame graphs. One example we found was that, so we do a lot of video processing, and we found that with our computer vision models, they were decoding all of the frames. And this was like a really simple no-op optimization that got us like 30% overall reduction in latency. I just think this is a really cool tool. So definitely check out PySpice, SnakeFizz as part of the integrations to RayServe. So next I want to talk about how we dynamically serve our models. So in IoT, we often need to personalize models based on incoming traffic to give customers the best experience. So we serve models after downloading on the fly from S3 with async non-blocking I/O. So always remember to use async in your endpoints. The models are kept in memory for speed with an LRU cache. And shout out to the team for developing, there's a model multiplexing feature out, which is out now, which does a lot of this for you. We implemented a lot of this ourselves, so it's really cool to see the Ray team picking that up. So after you're able to do this and you can dynamically generate your pipelines, we found it's really easy to delegate our model rollout management outside of code into something much more controllable. So we use like a feature flag system to control like which customers see which model. This also helps if your customers are on like different release stages. So you can target like, oh, this is on the beta sort of model. These customers are on the production model. It helps us just add another layer to our gradual rollout process. Cool, so next I want to talk about a few sort of deployment, productionization kind of lessons learned that we have. So this is our architecture about how we intend to perform our deployment strategy. So reiterating, Samsara has a strong culture of operational excellence where our top priority is making sure our apps work. So our requirement for this is we must handle deployments gradually on cellified infrastructure. So this gives us redundancy in our setup around single points of failure and reduce the blast radius of any issues. So we achieve this by splitting our infrastructure, our customer traffic across different cells. So like 10% of customers would be on one cell, et cetera, another one on another one. And we gradually increase that and deploy across each cell to get this sort of like a canary effect. So we do this with a GitOps pattern facilitated by Argo CD. So another keynote is that we also release our models with a shadow deployment. This is an industry standard for staging, where we replicate all the traffic prior to customer release. This really helps us capture and identify bugs. We can identify any like data drift prior to customers actually seeing the data or getting the ML models released to them. Cool. And then lastly, While coming up with our productionization story, we found that we needed an answer for issuing cluster upgrades for things like security patches, et cetera. So anybody that's working in enterprise, you're probably going to encounter this too. So you really want to make sure you have an action plan in place to handle all these sorts of like different upgrades across your system. So we manage this with a similar setup as before, kind of like a blue-green setup with a replica cluster where all resources are generated by Terraform, and we balance the traffic at the cluster management prior to deployment. Cool, so that's my talk. Thanks for sticking around. And of course, Samsara AI team is growing a lot. And if you're interested in working on real-world physical operations engineering problems in the IoT space, we'd like to hear from you. Or if you just want to chat more about Ray Serve, if you're checking it out, I'm on the Ray Slack. Please hit me up. I'd love to chat more and compare notes. Thank you.